Hello students, let us take the important chapter for NEET-JEE, that is gravitation. We will do the brief revision of this chapter. The main points we will discuss in this chapter, the main formulae as well as the few short tricks used for MCQ. So the chapter start with a gravitational force. Now, what is the gravitational force? That is the force acting between any two bodies. The force acting between any two bodies possessing mass is called gravitational force. Now we know that all the bodies possesses mass. So any two bodies possessing mass have a gravitational force between them, and this force is attractive in nature. This force is attractive in nature. Also, it is called universal law of gravitation. So whether the bodies are small or large, as far as they possess mass, there is an attractive force between these two bodies. So we can say mass is the cause of gravitational force. This law of gravitation was given by the scientist Newton. So Newton gave this law, that is the law of gravitation. Now, what is the law of gravitation? So, law of gravitation, we take two bodies possessing mass m1 and m2. So it has been found that the force between two bodies, say mass m1, body A and body B, the mass is m2. Both the bodies are separated by a distance small r, where r is a distance from center to center. So according to Newton, the force of attraction between these two bodies is directly proportional to the product of their masses and inversely proportional to the square of distance. Therefore, this force is equal to G m1 m2 upon r square. So this is the first formula, that is the gravitational force acting between any two bodies possessing masses m1 and m2 separated by a distance r. Here capital G is gravitational constant, and we will say that if we take a unit mass of both the bodies, say 1 kg separated by a distance of unit length or 1 meter, then the gravitational constant is equal to the gravitational force. So gravitational constant is equal to the gravitational force for the two bodies having unit mass separated by a unit distance. Its value, because it is a constant, its value is 6.67 into 10 raised to minus 11, and SI unit is Newton meter square upon kg square. Also, this gravitational constant is known as universal constant. So its value does not change because it is a constant of proportionality. So whether these two bodies are on the earth or these two bodies are on any planet or in the space, the force depends on the masses and inversely proportional to the square of distance. The value of capital G always remains constant. The mass is also a constant. So we will see that this force does not depend on the medium between the two bodies. So we will discuss the characteristic of this force. Now this force is attractive in nature. It means the body A is attracted towards B. So it is denoted by force on A due to B, and this force on B due to A is denoted by FBA. Now as far as this both forces are concerned, they are equal in magnitude and opposite in direction. So the magnitude of the force is equal and its value is equal to G m1 m2 upon r square. So as far as magnitude is concerned, the force between the two bodies are equal in magnitude and opposite in direction. So this is the law of gravitation. Then the dimensional formula. So this is the SI unit. So you keep this in mind. This is the SI unit of gravitational constant. Then the dimensional formula for Newton, it is mass into acceleration. Then we have a meter square, so L square upon kg, that is m square. So the dimensional formula of the gravitational constant is m minus 1 L raised to 3 T minus 2. So that is Newton meter square per kg square. Again, the dimensional formula is important. So these are the important points you have to keep in mind, that this force is attractive in nature and mass is the cause of the gravitational force. Now let us see law of gravitation in vector form. So in the vector form, we have to take the direction into consideration. If we have to write the magnitude, as earlier we have written F12 is equal to F21 mode, that is equal to G m1 m2 upon r square. So this is the law of gravitation in scalar form. This is the law of gravitation in scalar form. Now let us see the law of gravitation in vector form. So force acting on 1 due to 2 is equal to, now we have kept a vector sign here, so direction is involved, G m1 m2 upon r square. So this gives the magnitude. Now a unit vector r12 vector, that is r cap, is a unit vector. We know the unit vector have magnitude 1. A unit vector is in direction from A to B, from point A to point B. So the force on 1 due to 2, this force is attractive in nature, so body 2 will try to attract this body 1. So it is in that direction. So we write R12 cap, which indicate the direction. So this is a law of gravitation in unit vector form. Now if I take a law of triangle or triangle law of vector addition, we can write R1, so from the diagram, OA vector plus AB vector is equal to OB vector. So two vectors OA, AB are in the same order, then the resultant is the third side taken in opposite order, so OB. Now OA, that is called the position vector of M1, and R2 the position vector of M2. So this is R1 vector plus A to B. A line joining A to B is denoted by R12 vector. So that is equal to R2. So R12 is equal to R2 minus R1. Also, R12 cap, that is the definition of unit vector, a vector divided by its magnitude. So this R12 is R2 minus R1 divided by the magnitude of R2 minus R1. So we substitute this two formula in this equation. Now since this is the force between 1 and 2, we write this as R12 square. That is the magnitude. Whether you measure a distance from A to B or B to A, the distance is same and it is in scalar form. Now we substitute a unit vector R2 minus R1 upon the mode of R2 minus R1 on this side, and R12 can be written as R2 minus R1. So if I replace, let us say this is equation 1, this is equation 2 and this is equation 3. So if we substitute equation 2 and 3 in equation 1, F12 is equal to G M1 M2 R cap 12. So R2 minus R1 divided by R2 minus R1 cap mode, then we have R12 square. So R12 is R2 minus R1, but it is in scalar form. So again we write the magnitude R2 minus R1, the mode square. So in the denominator it becomes the cube of the magnitude of R2 minus R1. So formula becomes G M1 M2 R2 minus R1 upon the magnitude of R2 minus R1 cube. So this is the force acting on M1 due to M2. It means M2 will attract M1 towards it. So now M1 will also attract M2 towards it. So that is denoted by M2 F21. So similarly, from this equation, this is written in unit vector form. This is in vector form. So this is called the law of gravitation in the vector form. Similarly, we can write force acting on 2 due to 1. So if I want to write in unit vector form, it is G M1 M2, distance between 2 and 1 square. Then the direction of this 2 1 is opposite to this. So I can write R21 cap, or I can also write F21 is equal to minus G M1 M2 upon R21 or R12. As far as denominator is concerned, it is in scalar form. So I can write 1 2 or 2 1. And here I have written the minus sign. So I will write here R12. That is, from the diagram it is clear R12 cap is equal to minus R21 cap. So from this, we can also prove that law of gravitation obey the Newton's third law, because this portion is F12. So F21 is equal to minus F21. So this is the law of Newton's third law of motion. So law of gravitation obey Newton's third law. So it is proved here. So I can write similar equation now in the vector form. So R2F21 is equal to G M1 M2. Then we have R2 minus R1. So here it can be written as R1 minus R2, that is in opposite direction, divided by R1 minus R2 mod cube. So this is a magnitude. So if we interchange this, it does not make any difference in the denominator, but in the numerator here it is R2 minus R1, here we have R1 minus R2. So this, all the equations written in the box are important. So this is how we derive this law of gravitation. So I have derived this law. You keep a note of this all formula. Now let us come to the characteristic of the gravitational force. Now the first characteristic which is very important is it is always attractive in nature. So this force is always attractive in nature, and we will see the electromagnetic force or electric or magnetic force are either attractive or repulsive. Then it does not depend on the intervening medium. It means if the medium between these two masses is changed, in the place of air, suppose we have some other medium, say kerosene or any medium between the two masses. So suppose this is body M1, this is body M2, the distance from center to center is R. Suppose the medium is air. Now the medium between the same two bodies is replaced. Say now the medium is kerosene, distance is still R, the mass is a constant, so mass does not change. So whether there is an air medium or any other medium, the value of the force, the magnitude of the force in both the cases remain same, because G is a universal constant, M1, M2 is constant, the distance is not changed. So unless and until you change the distance between the two bodies or you change the masses, this force will not change. So second point which is important is it does not depend on the intervening medium. So whatever medium we have, the magnitude of force between the two bodies remains same. Also third point, it does not require any intervening medium. It does not require any intervening medium means even if we have a vacuum, between the two bodies, then also the force of gravitation or the gravitational force between these two bodies will remain same. So it is not necessary that this force require any medium. Even if it does not have any medium, that is it have a vacuum, then also this force will act, and the value in all the cases, whether it have a medium or it does not have a medium, the magnitude of the force between the two bodies remains same. Again we have proved this, it obeys the Newton's third law of motion, that is we have proved F12 is equal to minus F21, that is action and reaction. So this is F12 and this is F21. Then it is a long range force. Now it is a long range force means we know there is a gravitational force between the sun and the earth. So earth is revolving around the sun due to this law of due to gravitational force. Now the distance between the earth and sun is not small, it is a very large distance. Still this force exists between this sun and the earth, or you can say all the planets are revolving around the sun due to this force. So it is a long range force. Again, though it is a long range force, it is the weakest force in nature. So we know there are four fundamental forces in nature. One is the gravitational force, other is the electromagnetic force, third is strong nuclear force, and the fourth is weak nuclear force. Out of these four fundamental forces, it is the weakest force in nature. It is again 10 raised to 36 times weaker than electromagnetic force and 10 raised to 38 times weaker than the strong nuclear force. Then it is conservative force. Here conservative force means the work done by the gravitational force or against the gravitational force does not depend on the path followed. So if you are doing the work against the gravitational force or in the direction of the gravitational force, so when we discuss about the work we know is the force into displacement, that is actually a dot product. So whenever we do a work in due to this gravitational force, the work will be either done by the force or work will be done against the force. So it will not depend on the path. We will prove that it depends only on the initial and the final position. So if in any medium there is a force, and if you are doing the work against this gravitational force, or if this work is done by the gravitational force, the work done will depend only on the initial and the final position. Then it is a central force. It is a central force means this force acts in a line joining the two particles from center to center. So here M1 and M2, we know that or we have taken this distance r from center to center, and the force is acting along the line joining these two particles from center to center. So it is a central force. Then it is two body force. Now what does it mean? It is two body force means if we take a third body, say of mass M3, this presence of third body does not disturb the value of F12 or F21. So this magnitude is same. This is the magnitude. So if I place a third body near or in the surrounding of M1 and M2, the force between 1, 2 or the force between 2, 1 will not change. So the presence of third body does not change this value. Again, there will be a force of attraction, that is force acting on 1 due to 3, and there will be the force acting on 3 due to 1. So again, there will be a force of attraction between 1 and 3, but this M3 will not disturb M1 and M2, and again there will be a force of attraction between 2 and 3. So force on 2 due to 3, and this will be the force on 3 due to 2. So again there will be a force of attraction between this pair of bodies. So there is a force between M1 M2, M1 M3, M2 M3. Now these individual values will not be affected by the presence of the other body. So now if I take the fourth body, say M4, then this M4 presence does not change the magnitude of the forces acting between the two bodies. So it is called a two-body force. Now let us say superposition principle. Now in the system we assume there are n particles having the masses m1, m2, m3, mn. Now if more than two gravitational force act on a body, then the resultant force acting on it is a vector sum of the individual forces. Say if we consider two bodies in a system, then the force acting on an individual body is only one. That is, force act on 1 due to 2 and force act on 2 due to 1. But if there are more than two bodies or two particles in the system, there is more than two gravitational forces. So in that case, all the forces will have different directions. So you have to do the vector sum of all the individual forces. So that is a superposition principle. So let us take an example. We find a force on 2. So this is read as the resultant force on M2. You can find out resultant force on any particle or any body. So that is force on 2 due to 1, force on 2 due to 3, force on 2 due to 4 plus dash 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 force on 2 due to a particle or a nth body. So here different directions are shown. M2 will be attracted towards M1, M2 will be attracted towards 3, M2 will be attracted towards Mn. So F21, F23, F2 and have different directions. So resultant will be somewhere in between them. So that is F2 is the resultant shown here. Now we apply the law of gravitation. So F21 is written as G M1 M2 R1 minus R2 like this. You note down this thing. So this we have already discussed in the previous topic. This is the law of gravitation in vector form. Now here M2 is common in all the equation. So here we write 2 as common and I, the variable is given to 1, 3 and n. So we write G, Mi, M2 which is common. Then 1, 3, n are variable. So we name that variable as I. So Ri minus R2 upon Ri minus R2 whole cube. Now here we put a summation sign where I is running from 1 to n. I should not be equal to 2 because the body or a particle will not exert force on itself. So if I take I is equal to 1, then I will not be able to take I equal to 2 because I am finding the resultant force on this particle or body number 2. Then I will be 3, then you will get this term, then I will be equal to 4 like this. This is the formula for the force acting on the second body or M2. Similarly, suppose I want to find out force on any jth particle or jth body. So now instead of 2, I give that body name as J. So force acting on jth particle or jth body is I is again running from 1 to n. I should not be equal to J. So now this 2 is replaced by J. So if I am finding out the force on J, it should be Ri minus Rj, as we have done in the previous topic. So this is a superposition principle. It comes into picture when more than 2 gravitational forces act on a particular particle or a particular body. Then you have to simply remember that you will apply the vectors law, that is a triangle of vector addition, or law of parallelogram for addition, because the direction is different. So this is the general formula for the superposition principle. Now let us see the term gravity. So sometimes we call it a force of gravity or only gravity. It is the force by which body is attracted towards the center of the earth. It is the measure of the weight of a body. So weight of a body is nothing but a force by which a body is attracted towards the earth. So if we say our weight, my weight is this much, I mean by how much force I am attracted towards the center of the earth. So gravity here means the measure of the weight of a body. The weight formula is mass into g. We will come to this acceleration due to gravity in the next topic. So weight formula is mass into acceleration due to gravity. Then the unit, because it is a weight, or the formula is mg, it is Newton, that is kg meter per second square. This is an acceleration due to gravity, dimensional formula, mass into acceleration, and it is a vector of vector quantity. So gravity is nothing but a force by which you are attracted towards the center of the earth, or your weight is nothing but a force by which you are attracted towards the center of the earth. This force is always directed towards the center of the earth. Now let us come to topic acceleration due to gravity. So the acceleration produced in the body due to gravitational force of earth is called acceleration due to gravity. So in the previous topic we discussed the gravity or a force of gravity. So all bodies are attracted towards the center of the earth. So the acceleration produced in the body when they are attracted towards the center of the earth is called the acceleration due to gravity, generally denoted by small g, SI unit, because it is an acceleration, meter per second square, dimensional formula, L1t minus 2. Again it is a vector quantity because it is an acceleration, so it have a magnitude as well as direction. Then let us see the general formula for acceleration due to gravity. So consider a body of mass m at a distance r from the center of the earth. So here small r is the distance of a body of mass m from the center of the earth, re is the radius, and m is the mass of the earth. So the force acting on it, or this is a force of gravity, that is m into g. Or you can say the force acting on the body of mass m due to Newton's second law is mg. Now the force of gravitational or the gravitational force between the two bodies. So we have now two bodies, small m and capital Me, that is the earth. So that is the law of gravitation, Me upon r square is equal to mg. So mm is cancelled. So g is equal to gme upon r square. Now you see this formula. This is called the general formula of acceleration due to gravity. And it is clear that g does not depend on mass of a body. Does not depend on mass of a body. That in fact it depends on mass of planet and distance from its center. So it is inversely proportional to the square of the distance. So clearly small g depends on the mass of the planet. Here we have taken Earth. So general formula becomes g me upon r square. Now if this body is on the surface of the Earth, then small r is replaced by the capital RE. So on the surface of Earth, GE becomes GME upon RE square. The value of G on the surface of Earth. So if any body is on the surface of Earth, the acceleration on the surface of Earth is 9.8 meter per second square. We can verify this by substituting the value of capital G, which is 6.67 into 10 raised to minus 11. The mass of the Earth is about 6 into 10 raised to 24, and you have to remember that the radius of the Earth, if we assume the Earth to be a circle, a sphere. So if we assume the Earth is a sphere, then its radius is 6,400 kilometer. Though Earth is not a perfect sphere, but for the gravitation chapter, we assume that Earth is a perfect sphere. So its radius is 6,400 kilometer, which can be written as 6,400 into 10 raised to 3 meter. So we substitute this value here, 6,400 into 10 raised to 3 whole square. So if you do the calculation, the value of small g comes out to be about 9.8 meter per second square. So this is the value of small g on the surface of the Earth. Otherwise, small g is inversely proportional to the square of distance of a body from the center of the Earth. So small r is from the center of the Earth. Now small g also have a relation with the density. Here we are considering a planet to be a Earth. So GE is equal to capital G. In the place of mass, we can write the density of Earth into the volume of the Earth, that is 4 by 3 pi RE cube. So we know that mass is equal to density into volume, or density is mass upon volume. So we make the use of this formula. So therefore GE is equal to 4 by 3 pi, then r cube is cancelled with this r square. So 4 by 3 pi g, then rho e RE. Now if we assume that the density of the Earth is constant, then the value of acceleration due to gravity is directly proportional to the density. So this is the general relation. Here we have taken the planet to be Earth. So for any planet, the acceleration due to gravity is directly proportional to the density. More is the density of that planet, more will be the acceleration due to gravity. So this is again an important relation of G in the terms of a density. So you can use this formula for any planet. Now let us see the variation in the value of the G, small g. Now let us see the variation in the value of G. If the radius of planet decreases by n%, keeping its mass constant, then the value of G increases by 2n%. So if there is a decrease of say 2% in the value of the radius, or the radius of the planet shrink by 2%, then the value of G will increase by 4%. Now this is the shortcut you can remember. We can prove this, that for any planet, G will be equal to G, mass of the planet, upon the radius of the planet square. Now we have to find out the change. So we differentiate this equation with respect to r, because the mass is assumed to be constant. So differentiating this equation, dg by dr, so it becomes minus 2 gm upon r cube. That is, taking r raised to this r square can be written as r raised to minus 2, and then we differentiate this equation. So this is equation number, differentiating equation 1. This can be written as minus twice gm r cube dr. This is your equation 2. Now we take a ratio. So dg upon g, that is this equation divided by this equation, it comes out to be minus twice gm r cube dr gm r square, that is g value. So gm r square is cancelled with this r. So you are left with dg upon g is equal to minus 2 dr upon r. So this can be read as dg upon g, that is change in g upon the original value, is equal to minus twice dr by r. So multiplying both sides by 100, so we can get an answer in percentage. So this equation can also be written as, sometimes we write this equation as delta g upon g also, or this can also be written as final value minus initial value upon initial value also. So that is change. Delta means change. If the change is very small, we use the symbol for derivative. So delta g upon g is equal to minus 2. Now the change, the radius of the planet decreased by n%. So we can write here minus n. So it becomes twice n. So multiplying both the side by 100, we get an answer in percentage. So if it is an n% given, so percentage change is equal to twice n percent. Similarly, if the mass of the planet increases by n%, so now the mass is increasing by n%. So this is the proof of 1. If mass increases by n%, then the value of g also increased by n%, because g is directly proportional to the mass. Here in this case the g was inversely proportional to the square of the radius. Here we have to do the derivative. So if we want to prove, we can also prove this, that g is equal to gm upon r square. So dg can be written as capital G r square dm. So that is differentiating g with respect to mass. So this is your equation 1, this is equation number 2. So now we can take dg upon g is equal to g upon r square dm gm r square. So r square cancelled, gg cancelled. So dg upon g comes out to be dm upon n. So now there is an increase of n%. So percentage change, this can be written as n, because it is given, it increased by n%. So multiplying both sides by 100, percentage increase is equal to n%. So this is change in g with respect to the mass. That is, if the mass of the planet increase or decrease, it is in direct proportion. It is in inverse proportion because we have a square, so it becomes 2n%. Now third, if the density of the planet decreases by n% keeping radius constant, then the value of g decreases by n%. Again, small g is equal to gm upon r square for any planet. So we are talking about the g on the surface of any planet. This mass can be written as the density into the volume of that planet. So this comes out to be 4 by 3 pi gr rho. So clearly g is proportional to rho if we assume R to be constant. So if G decreases, if density decreases, then G also decreases by n%. Or again, if you want a differentiation method, dG upon G comes out to be d rho upon rho, or we can write delta G upon G is equal to delta rho upon rho. So in percentage, it comes out to be n% decrease, that is in the direct proportion. So radius is in inverse proportion, but it is square. So we have minus 2n% or plus 2n%, depending whether the radius is increasing or decreasing. Mass is in direct proportion. So if mass increases, G will increase. If density increases, the G will increase. So this is the variation of small g in the terms of the radius, mass, and the density. So the general formula: if a body is away from the center of the earth, then general formula becomes Gm upon R square. So if a body is at a distance small r from the center of the earth, so you have to remember this. Then on the surface of earth, we have Gme upon Re square. For any planet, you write its mass and its radius as we did in this variations. So this is we have for today's lecture. In the next lecture, we will continue the variation of G with respect to latitude, altitude, and the depth. So the value of G we will see as we move away from the center of the earth. It will change with respect to height. That is called as the variation in G due to altitude. Then if we go inside the earth, then there will be a variation of G due to depth also, and due to the rotation of the earth also. We have the change in the value of G, which is on the surface we have taken to be 9.8, but this value of G will keep on changing. So in the next lecture, we will see the variation of G and the formula related to it. Have a nice day.